Initially, what occurred to me was to buy expensive polymer dissolution solvents, and we invested a lot of money on that. Polyether, polyxylene, all these things will cause the degradation that I had in mind, but it was not profitable. But eventually, I was able now to get a local material that could do the same thing for me. What have I done in what I have in my hand? The polymer sachet that you and I are familiar with, being polyethylene, will not allow water to go through it and will not allow oil to go through it because it's in a failed state. Now, after my reaction, what happens is that I'm able to create a lot of porosity inside the particles that result. This particle is highly porous, but the nature has changed from that original film stage in the sense that we now have a material that has a lot of capillarity. So, using two properties of these particles, I'm able to selectively draw oil and organic compounds and leave water intact. So what I have here now is a material that is still polyethylene cells because it's from the polymer sachet. The difference now is that the property has changed from original oleophobic, hydrophobic to now hydrophobic, oleophilic. By oleophilic I mean this material is now craving to absorb 6 to 10 times its own mass of oil or organic material. And initially, when this product was made, the connection was not made. It took a few days after making this in the laboratory before I realized that this is the solution for oil spill management. Why? Because when there is oil spillage, oil stays on top of water indefinitely. We are able to show, and I'm going to show you in a minute now, that this material with less than SG, a specificity of 1, also is going to stay on top of water indefinitely. The nature of it that is appealing to me as a chemical is what I now have. Originally, it was oleophobic, hydrophobic, so it could not be used to mop up or absorb anything. But the nature is now different. It is still hydrophobic. It will not allow water to go into it. But it is now highly oleophilic. And that is the magic you need to do oil spill management. The good thing is that because we are able to, initially I was making it in wafer form, like cornflakes. But now, using a different method, I'm able to get it into powder form of any particle size. And what that does is that it allows me to pick up spillage, whether it is organic material or oil, on the ground, on water, sea, or even on top of trees. Because what we can do is that when it is a ground floor spillage, all we have to do is sprinkle the powder on top of the spillage, allow enough time, I'm going to demonstrate that, and in no time you will see that the oil is already contained and absorbed. You can sweep it up. I'm going to come back and talk about that. If it's on the sea, the story is better because you are going to have the wave of the water, whether it's river or ocean or sea, helping you. Once an oily material or organic material contacts this, it is no longer going anywhere again. It stays put. It gets absorbed. And therefore, just like on the land, you can also pick up any oil floating on top of water, whether it is river, sea, or ocean. Now, I mentioned that this has an advantage over what is available in the market today. If you have oil accumulation on leaves of a tree, it is very difficult for you to use the material that is used today. They call it blown microfibers. That is what is available most times when people are trying to do oil spill management. But I have an advantage with this powder in the sense that the same way I'm able to contain spillage on the ground and on water. If we are able to shoot this into the leaf is going to get attached to the oil on top of the lid. Remove the oil from it, we can sprinkle it down, and now it will now be loaded with oil. Now, the amazing thing about this material is that removed from where the spillage occurs, one can take this oleosorbent loaded with oil and squeeze the oil out if one needs the oil. That is one big advantage. So you can actually even do oil recovery, but each time you squeeze out the oil, you are now able to use the same material over and over again. That is another advantage of this particular material over what is available in the market. What I will do quickly is show how the oil mock-up is done. I will have water in two places. Right, please. Not just for the crude oil. Anything organic preferentially is captured by this oleosorbent material, but the water will be left untouched, as we are going to see in a few minutes. We have crude oil that was given to us courtesy of our NMPC. And I'm just going to put crude oil here. Here. The natural law of science is obeyed with SAS and mass in the sense that we expect crude oil to flow on top of water and it is floating. What I'm going to do now is try to contain the spilled oil on top, and there is a process I want you to catch note of. That is the sense that if I start putting the particle in the middle, it is able to draw the oil to itself. But normally when there is oil spill management, what we try to do in the field is to prevent it getting into a large area before trying to contain it. So naturally, I'm going to start in the middle somewhere to let you see the shrinkage in the accumulation of the oil or drawing it to the center. And I'm going to do one that encircles, but in both cases, you are going to see that it becomes relatively easy for one to just come and pick only the oil away for recovery at a remote location and leave the water intact the way it was before. So in one of them, like I said, I'm going to sprinkle outside.
Excuse me, sir.
Yes, please.
I think we are supposed to be interjecting, so it makes it very interesting.
I will stop anytime you want. Okay. What I'm doing is, if you come here, you will see that immediately it's going into action and absorbing the oil. The volume, the area at the end is what I want you to see, because in one I'm starting at the edges, but in the other one I'm going to start at the center. In either case, you are going to see that there is shrinkage of surface area, but in this one now, you can see the volume is almost immediately, sorry, the area is collapsed immediately. But in that one too, you can see the oil going into the layer of the absorbent immediately. But the good thing about it, by the time I'm done with this, the volume here, so the surface area here will be less than over there. In other words, that is why we have different gradients over here. In instances where we want to absorb major speed in the middle, we will put a pillow, and the pillow can be 4 or 5 times what you are looking at. We have just made a small prototype for you to see. We can also make booms. Booms usually contain the spillage area to keep it from spreading further. So we can make this as long as possible, almost like a donut ring. We can surround a spillage. And as we are seeing here, the oil just gradually goes into the absorbent. And all we need there is a scoop. The scoop now we just take the whole oil and leave the water intact. Incidentally, this tells me I need more. Yes. So. But I don't want to go to the end, like I said. I want all the containment to be done from inside. What concerns is that if you want to minimize spread, the earlier we get to the middle of a spill, the better. In other words, we can actually draw in the spillage. But as is presently done, when we have the booms, we can also surround the area of the spillage and just inwardly draw the spill into the booms. So that is the mechanism. We are going to pick this up. Actually, there is a video. I can pick this with my hand because this is now loaded with crude oil. I can almost like cake. I can pick it up.
Sorry, sir, I have a question.
Yes.
If this is a very calm environment,
yes.
What is the application of the highly energetic environment, let's say the sea?
And I'm saying that actually helps me when we come to mechanics. No motion, I'm having absorption. But the issue is that anytime oil contacts the surface of this, the oil stays put. But the water that comes along with it, that is what I'm showing you. So actually, it is aided more by motion than the static surface of water.
And what of the aspect of application? Let's say if you have a very windy atmosphere,
Yes.
How do you apply?
That's what I'm saying. That is why we have brought the bones and the pillows. Well, it is the principle we want to show
when
you.
you put the boots, the oil will surround the oil. Only water can pass through, or will not pass through the boots or the pillows.
So anytime crude oil and water touches the boom, the oil stays behind, but the water brushes up.
Are there other classes of this boom? Because I mean, the turbulent environment, the booms like this
It can be bigger.
We have very long ones also.
That's why I said we have brought you prototypes. Actually, we made ones 3 times the size. Again, the boom can vary in size.
I'm joined together.
And to join together to form a link around the spillage.
And sometimes it is possible to have a long boom, attach it to pilot boats,
To draw
and then it moves in a direction and it takes everything on its path along with it. Usually that's what happens.
in a situation where you are applying it directly to water, you can see you need really some great quantities of this.
But no, oil spillage management is large volume consumption of absorbents. You know that.
So what I'm talking about now is the cost benefit ratio of this.
Oh, well, sirs, if you look at what we are talking about, I'm not starting from an expensive polymer material. I'm starting from polymer waste. There is going to be a price to it because the way we look at it futuristically is that we are going to ask young men or women to bring disposed sachet to a center at a price. We are going to do the processing, but after that processing, the oil industry can benefit from using it for spilling management. So we are looking at abatement in tourism, abatement of waste in the sense that we are able to take the sachet off the road, and now spillage control through the use of this material.
But the employment opportunities for
A lot. We are thinking a lot of
You have a
employment.
win-win situation.
Yes.
Less environmental mess and
Also disposing polymer waste that will take almost 50 years.
excuse me, sir.
Yes, sir.
Has this product been used in real life oil spilling station?
Yes, where I got this was from an uncle that was in Warri, and I carried because I had to convince them because they gave us 50 liters of crude oil. I had to go there and demonstrate that this can work on. I went there with a pillow, and we were able to see how quickly the pillow was loaded with the crude oil, and we took it out. Because another thing I could have done, and it's still not late, is that I could have drop a pillow in the middle of this to also soak it into it, and then we just lift up the pillow, and then that pillow is ready for squeezing out and reuse. No, not good enough.
Different principles.
No, well, because I allow this one to spread, that is why the area is wider. But remember that I start my attack here from the middle, so it is all actually drawing everything into it. It's the same amount that I put in both of them.
You want the ceiling?
I think you can just rip it from the ceiling. Okay, just rip it from the ceiling.
So, sir,
Yes, please.
are you saying what we expect to see in this CD is real life application of this software in student management?
No, this is what
What was demonstration in Lagos for DPR? We went to about 4 places. Again, before I was made VC, I was going around the country with Mr. Obulela here. We even went outside Nigeria to demonstrate the efficacy of this invention. The issue then is we went to 2 offices in Lagos, I think NLPC and DPR, and we were able to show them live how this thing could be used. For the day,
NLPC office in Lagos.
okay, was it?
Not Abuja. We also came to our head office in Abuja too.
We talked about registration. I don't know, was that done? We came to an office on the right wing as we came in, not turning left. This was about 6 years.
Of registration, which we are going to actually at the end of the program, we are going to communicate to you, because we are still going to review the whole program and find out whether it is suitable in the Nigerian environment. Because if before we start going and recommending products to be used for use in the Nigerian environment, we have to be cocksure that we are not going to, at least people will not be, being a sensitive environment, people will not come up with some issues. So, having said that, we still think that there are 2 levels of registration. It's either for you to register as consultant, which is not going to be a barrier anyway, and again to register the product. Another aspect of it is when there is or there are speak conferences all over the world. We have been witnessing issues, products like this being brought from the Western world. This is a Nigerian product which, if there's continuous engagement with the agency, we will be going there to present, to showcase, and at least to demonstrate that Nigeria can do things even better than the ones we have been trying to patronize. And in the other industry, they used to have there will be, if this product is registered, you have the opportunity of going around taking the products around the operators, so that they will know, they will be familiar with this product. Foremost, they will be asking for the agency's accreditation or approval, and that will put the products in a good platform with other products that is in the market. And if we are able to get all this, they are buying in, I think it will be a breakthrough, not for even the product per se, but for OSP response management in Nigeria, so that we don't start depending indefinitely on technologies outside this place. So, and on this note, I think we would like to congratulate the Prof and his team, as they have come a long way in trying to showcase the Nigerian genius in this on this issue. We have seen booms and all these things, and we never commit. We thought it was not going to be a Nigerian invention until we come about this idea. Even the way we are seeing it, even if it has not gone out, I think we will need a very, very good encouragement. And that is why we say that in the process of trying to get this thing out there, the certification will be very, very, very important. And from there we can start looking at how to even tell the oil company to at least patronize Nigerian products, which is even a very good and strategic thing to do. So I don't know whether the prof is having another issue, any other thing to discuss.
Except that I just want to say you to what you have not said. I thank you for recognizing that at least in-house we do some of the wonders that have been done in the West. I want to tell this body that when I finished my PhD in 1988, for 4 years I was with 3M company in Minnesota. They are the biggest makers of boom production, and I was the lead engineer in research lab for 4 years. The method they had, which I didn't think I could do it other ways, was using extrusion process and very high velocity here. It takes the size of twice this room for us to produce the blown microfibers. I know how to do that, but it's an expensive process and the product is equally expensive. But in trying to solve the problem of waste generation in Nigeria and trying to abate it is how this idea came about. Everything about this process is only available. Nothing is imported. That is one thing. The price is way, way, way below what you are going to pay for the blown microfibers. But you can see, this, unlike the webs, is using two abilities of the particles for absorption of the oil now. I'm using not only the porosity of the particle, because these particles now are not filmy again, they are highly porous. Number one. The other one is that the capillary action that the web is using, this is able to use it better in the sense that it is not a fiber, it is a particle size, and therefore can have larger surface exposure to the speed oil. So comparatively, we have a material here that is performing better than what I, as an expert with 3M, did for 4 years when I was working with them before returning to Nigeria after many years with them. Thank you. Now, we are going to do two things. And what I will do is that we are going to do oil spill management using particles and using pillows that we have prepared. One good advantage of this particle size material is that you can apply it directly as a particle, or you can package it into pillow sizes or into booms according to specification. What I'm going to do right now is show by pouring crude oil on plain water inside this green bowl and pour the same crude oil on the one inside this tray. Now, you have to go to the other side. This is crude oil being poured on you can see it floating to the top. I formed a pool of crude oil in the middle of water, as you can see. Now, I'll leave that one, and there are two ways we can go about this. We can either use particle to pick this one up and use pillow packaging to pick this one up. Maybe you should stop again. But what I'm going to show next is that you will see that when I pour crude oil into the water layer already having these processed particle on top of it, it will actually be contained in the middle to not go to the side of the bowl. And that is what I'm doing now. It will be completely contained in the middle, because what I'm doing is that I'm putting it on a surface where there is affinity for oil. Now, we expect the oil to go to the side of this bowl, but it will not go, because in essence we have given the oil a surface onto which it can be absorbed, and that makes it impossible for the oil now to go to the edges of this bowl. But what I'm going to do now is take a pillow loaded with the same particle and use it to absorb the oil that I put in the middle of the green bowl. It actually goes into action immediately, and you can see that the volume of oil is already beginning to decrease. Everything will go into the body of this pillow packed with the absorbent particle that we have produced. Again, you can see the volume of the oil just shrinking and going inside the pillow. That is how fast the action of this oleosorbent particle is. It's able to completely contain oil spillage, either in the particle form or packaged as a pillow or as a boom, depending on what the user specifies for packaging. The oil that I made sure I poured it into the middle of the green bowl. What has happened essentially is that all the oil is now completely absorbed in this pillow, and it will stay so until this particular packaging material is calendared to squeeze out the oil. The oil is captured and captured permanently. There is no leakage of the oil once it's inside the porous particle. What I'm going to demonstrate next is how to use the oleosorbent particle to remove oil that is on the floor or on the soil. I will let the oil spread for a while and just come round and put the oleosorbent particle first around it to stop it from spreading. And actually, the beautiful thing is that without even putting it on the oil itself, once the oil is surrounded, it will just on its own go into the spillage. But for a quick action, what one can do is put the oleosorbent particle on top of the oil and just simply mop it up once the oil is picked up. We will allow about 2-3 minutes to be sure that the oil is completely absorbed by the particle, and simply mop it off the floor. What I'm about to demonstrate is how to pick up spills when it is on land or on a hard surface. All you have to do is sprinkle the oleosorbent particle like I've done over it, and after a few minutes just come round and you can see it being picked up along with the particles to leave a clean surface almost as if there had been no spillage at all. Well, I will mop up the rest of the particles. And all one has to do, if one needs the oil back, is go at his own convenience to a remote location and recover the oil from the particles by calendering the oil out of the particles.